right, stream. Yeah, just game engine stream. Welcome to the game engine stream. Let me see if I have any news or anything. I don't think I have anything in particular. Last stream, I had someone come in and help me with what is it called? Strings. And yeah, I realized that I do need to fix my string situation in my engine. I'm not going to fix the whole thing right now because that's a gigantic task I don't feel like doing right now. But I will figure out a new system for the strings and start using that API instead of how I currently use strings, which is just using STD strings, right? Quite wasteful on performance, right? Lots of heap allocations and whatnot every frame. So I think this stream for today is going to mostly focus on just getting these strings working. And then if I finish working on the strings and I kind of get like a workflow or how do I say workflow, and get them working in a way that I like. Oh, actually, let me fix my webcam really quick. All right, there we go. But yeah, if I get them working in a way that I like, then I'll just continue with what I was doing last stream, which was fixing up the content browser. So let's continue on with strings. Let's see. Yeah, I believe I'm still in the same commit right now. I'll go ahead and commit once I get these strings in. So without further ado, let's go check out these strings. So yeah, I got C string here. This just returns C string. I got the size. This just returns the size of the. I believe this is the buffer. So let me see. I think I should be clear about that buffer size. And it's taking a second. Yeah, and I'll start moving around strings more as like const car pointers than anything. The only thing is if I want to modify the string, I gotta think of how I want to do that. Okay, this grabbed a lot of information. Okay, never mind. I don't even use this anywhere, so I can just do buffer size. I guess it just took size and it was like, you meant every single size in the entire engine? Yeah, that's what I meant. And of course, mdata is probably going to do the same thing. It's like, you mean every mdata in the entire engine? Yeah, that's what I meant. So I'll do mdata buffer. Still gotta get a new mouse, let's see. So again, you can initialize a fixed string with a const car pointer if you want. I didn't add the actual API for doing this yet, but yeah, I need to finish this. Early out def new size of string exceeds buffer length. And really, I think there's a bug here too, because dot at length plus 1, right? Because this is the null terminator. You always need to worry about the null terminator. Because you want length plus null terminator, right? Can't forget about it. Then SSD string copy. So we're going to copy the data buffer from the current length so I'm going to call this m string length. String length, m string length. I don't know. I know to some people this is like way overly verbose, but I don't care. I'd rather be extremely clear about what I'm doing rather than having everything succinct. So SSD size TN, right? So this is going to be max. Let's say buffer size. And then let's put it right here. There we go. Oh, wait a second. I'll say get. Well, this isn't the buffer size. I don't know what I'm talking about. Gets. Oh, I'll just do length, I guess. String length. Size of newly appended string. It's the string. There we go. Early out if new size of string exceeds buffer length, right? Otherwise, we're going to go ahead and fill buffer. Fill fill data after current length. Fill data, and say overwrite, right null terminator. Yeah, overwrite the current null terminator, just to be clear. Then add new null terminator. Here we go. So now it's very clear. This get size and delete pending string, early out if new size string exceeds buffer length. Wait, this string is greater than or equal to buffer size. Yeah, if the string length plus the appended string length, which is the new length, plus 1 is greater than or equal to the buffer size. Well, I guess if it's greater than, because if it's equal, I think that technically is allowed. Wait, how was this prior? Wait, what did I just do? Hold on. Yeah, okay, well, I think this is pretty clear. It's like length plus append length plus the null terminator is here, right? Okay. I don't know if I should put these above or below these. I think I'll put them below. Yeah. Make it like that. Constructors plus destructors. Alright, so we can append, we can get the current length of the string, right? We can get the C strings so that we can do like C string operations with it. I think another one we might want to have is like maybe replace, or like maybe I'll do like an override of like the equality operator. Let me see. So if I do, I always forget how to do operator overloads. Let me see. Operator overloads. And then let me just yoink this really quick. Bring it down. Getters slash setters. Yeah, let's do some overloads for this new string class. Totally forgot how to do an operator overload. Let me go check. Operator overload. Plus. Yeah. Just take me to the overload. Okay, so it's something like, okay, I'm just reading up on it. I see one where it's like this. So we'll override the equality operator. And then of course. So I wanna first do the one where like I set it to a new C string. So let's car pointer, new string. Assuming I could just do this, and then because of this complex, we find operator overload assignment. Let me find a good example of assignment overload. Oh, okay, so here's an assignment overload. Let me put it down here really quick. So sure, why not? So in this case, we want to return a reference to this for like chaining, I guess. So that's fine. We'll do a fixed string. Reference. And then here, we're going to do a few operations. But at the end of this, we want to return like the key reference to this. I always want to do that. It's basically going to be this, to be honest. But the only things I don't know if it's like the append will provide a boolean stating whether it failed or not. This one, I don't think it will say. It might have to just like silently fail. I'm not dealing with exceptions for that. So yeah, I'm just gonna let it silently fail. It's fine. So get size of new string. New C string. New string. So it's going to be new string length. Going to be new string. Okay. Yeah, so in this case, we don't care about the current length because we're like literally doing an assignment, but we still want to care about the null terminator. So we want to make sure that this +1 is not greater than the buffer size. Right. I guess just return the dereference to this, right? Otherwise, so like this just won't do anything to the current class. Otherwise, we don't want to do data as a buffer that length. I wonder if it's worth it to like memset the entire data buffer to like 0 and then do it, or just leave whatever garbage data is in there and then just write in the new stuff. I think it's fine just to leave the garbage data in there, like, cause like I mean, as long as I put the data and then I put the null terminator at the right place, the C string should still be able to work and everything. So really, I just need to get the data buffer. I don't need to increment its length. We already know that the length is appropriate for the new string. So we start with this. I always forget what a string copy does. Let me see. Append string. So this is the data source, and it's just a const card pointer. So yeah, that's fine. New string. And then you just want the length of it. So new string length. There we go. And then we set it equal to new string length. There we go. And then we just, at that length, we set the null terminator. And then return this. But yeah, I think that's fine. Then it should operate normally. I guess when I need more operators, I'll just add them as needed, right? Type of thing. But yeah, you can append to the current string if you want to. You can assign a string. One thing I might want, right, is maybe like setting a particular location in the buffer, so like a new string, because I'm immediately going to use that soon. So what do I call that? Let's see. Bool set substring. Substring. And then we want a substring, new substring. And then maybe like a location inside the buffer. So I'll do a std size t buffer location. Right, and then this is gonna need a lot more checks. Still gonna do essentially the same thing, but yeah, it's gonna need a lot more checks. So same thing here, for the most part. Well, let me write out the pseudocode first. Get size of new string. New substring to be added. Now here's the thing: we want to early out if the size of the string plus if size of the string plus what is it, plus buffer location exceeds the agreed buffer size. Okay. And then we just fill the data like normally. So fill data. And then I guess I'll just put this here as well. And we'll go ahead and add the null terminator. I'll say if necessary. And I need to determine that. So this one just checks if like it's even possible to do this, like period, right? Yeah, this one's actually fairly complex. You know, I think I'm gonna table this one for now because I think for the most part, when if I'm gonna build up a string, I'm usually just gonna use a bunch of appends for now. Yeah. Add this if necessary. I'm gonna take a quick look at my old stream. Give me a second, because I want to see what man said. This one's broadcasting. This is the one. Sorry, they're gonna beat that. All right, take a look. Actually, maybe can I read the chat from here? Let's see. Cancel. Just view this video somewhere. Let me go to my channel really quick. Okay, and I can go to videos. I'm just looking through my Twitch really quick. And where are the? Oh, I can't look at videos right now because I'm streaming. I suppose so. I guess I'll just ask ChatGPT for now. I don't know. Formatting using what is it? The file strings. Fixed size buffer, way dynamic allocations, and then the sn print f data in buffer will exceeding error checking. I'll show you what I'm looking at right now. Let me bring it over. Okay, so I think I did something similar to this recently. I think I did it inside of my content browser. Oh no, inside my editor UI. That's a good key. Yeah, oh, this is the header file. No, I want the C++ file. So I did all the changes like right here. Oh wait, I don't want the diff. Just give me the actual editor UI. Let's take me to grid where I was working. So I was doing this. The cars. Okay, so we did two cars for a particular like data element. Okay. And then it just, okay, so then we specify the beginning buffer location and then the ending buffer location, right? And then, so this is like the total size of the buffer that we can use. And then we provided the particular integer that we want to convert over, and then this provides an error code, whether it was successful or not. And in this case, yeah, we did this and this here, which was cool. And then we did 2 cars. So I might want to add this as its own like thing. Yeah. Inside of the string class. Maybe like append variable, maybe? Maybe I can call it that, yeah. Yeah, because I have to write the null terminator like myself here. So this prints an error code whether it was successful or not, and then provides a pointer back to the location, and we can just set that pointer here. I'm just trying to think if like there's anything I can do like to check prior to trying to do this operation, but I don't think so. Also, it makes me specify the end of the buffer immediately, which is interesting. I mean, I suppose if I append to my string, then I can kind of handle that myself. Okay. So I'll say append variable, I guess. And maybe I'll make like a template class or a template function. Yeah, so I'm gonna yoink this for a second. And come back. Okay. Say bool and variable. I could do overloads, or I mean I could just do a template. I'll say type name T. I'll just do T for now. How would you? How can I make sure the I'm writing a template class. How can I make sure? Because I know I could do static asserts. I know I could do static asserts. I just don't remember how to like assert that the type is like a simple like printable type, I guess, or like a very like simple, not like a crazy, you know, like complex type. Maybe I can just check, because I think I've done that before in the engine somewhere. Let me just look for a static assert. Oh, here we go. Yeah, so static assert entity is integral. Right. So what other ones do I have? It's std is arithmetic, is array, is fundamental. I am going to static assert this really quick. Because right now I only want to support like integer values. Where was I? Where's my string class? Okay, here we go. Let's go ahead and then not this, but we're gonna do key value. I'll say append integer. Integer. And only append simple integer types. There we go. So let's do a static assert right there, and then integer type. I start using t underscore for a template. I guess I'll just stick with normal t. What ways do people use C++ programmers typically name their template arguments other than these come from mention there are various descriptive names type, so there's given name, right? Sure. Yeah, I suppose. Yeah, you know what? I'm gonna do it. I'm gonna do it. Make up my own thing. It's my code base. Whatever. So t underscore buffer size, right? Sure, why not? There we go. Well, at least to me, it'll be very clear. They're like, oh, this is the template argument. Sure. Okay. So after we assert that this is an integer type, then we're essentially just going to do the same stuff that I did earlier. So let me head over to wherever I was. I think it was editor UI.cpp. Here. Yeah, so let's just go ahead and grab this real quick. I'll just put this here for a second. And I'll go ahead and break it apart. So this is as easy as just adding like an append to the string, so this is the real like meat of this thing. And then if we're appending, then basically we can just do data plus m string length, right? That way we'll overwrite the current null terminator. Okay, then this provides the remainder of the buffer, right? So if we do id.data plus id.size minus 1, then this will be the last like usable address of the data. Actually, it might be -2, isn't it? Because you go -1, because okay, because you would do -1 because if you're at the beginning of the buffer, right? So like the beginning, like if I had a size of like, I don't know, like 5, right? So I have a size of 5, and then I have like the characters 3, 2, 8. I don't know, 56, 5, and then have a null terminator, right? So the total size of the buffer is 5, sure, right? And then the way you would address each one, like if you got like, how do I say? If you got like ID, or in this case, it would be, what is it called? mdata. If you got the data pointer, then it would be addressing this first one, right? And then if you go up the size is 5. So if you go up 1, 2, 3, 4, 5, and then you're one past the size of the buffer, so that's not valid. So you would go back 1, and then this will be the last like addressable space. But you'd actually want to go back another 1 because you always need space for the null terminator. So in this case, we actually want to go back 2. Let me make sure my other code makes sense too, like given this logic, right? So get the size of newly pending string, right? So size early out if new size of string exceeds buffer, and again we have current length plus new length, right? And then +1 because we want to make sure that this plus this, because if you have a string of like 5 characters, that could fit into a buffer of 5 for sure. And if you have a string of 5 plus the length of the newly appended, then that would just be straight like the total, right? If you add, but you also had to add 1 because then you always have to add a null terminator at the end, right? And then that has to be greater than, or like if that value is greater than the buffer size, then we have a problem. It's actually fine that this value is equal to the buffer size because that's actually like a valid number of spots to be in its buffer size. So the only cases where, yeah, so this is fine. And then fill data. So now we know that adding this in is going to be fine. So we just take the current data, add the string, plus string. So we get the location data after the length, pretty much at wherever the current null terminator is, and then we add that string, right? And then we just add the length here, and then we set the what is it called? The data buffer at that length to null terminator, right? Because yeah, if you think of the length, you'll have that place, and then we can go up that length will actually be the one character after our final character because of the way I don't know, just the way that works like with this. So okay, yeah, this looks right. And then I think the other one where I do this as well is fine because get size, early out if size, because again we only have to worry about the new string length, we don't need to worry about the appending or anything. Fill data, do the same thing we did before, but this time we just go straight here, and then we just add null terminator. And it doesn't matter, whatever else is in the buffer doesn't really matter because we're putting null terminator at the right place here. So everything else in there could just be whatever it wants to be. Does not really matter. Okay. Okay, so I just wanted to make sure that made sense in my head. Okay, so we assert that we're using a simple integer type. Okay, so for this one, we're still doing an append, so you want data. So this is going to be the data buffer. Data buffer. We can get rid of this ID thing, whatever is going on here. Yeah, and it is garbage anyways. Okay. Yeah, we got an error code. Yeah, that's fine. I'm pretty sure these are like small values. Because if you go error code, is it really just neon? Oh yeah, and then okay. It's not specified, but I'm assuming it's just like a regular integer, so it's not that bad. Copy over. Especially if it's below the minimal addressable size, like 64 bits for a pointer, then yeah, it's fine. With an SD 2 cars, and data buffer that data, and then M string length. Is that right? Yeah, M string length. Yeah, and we want to make sure we did this -2 because of this thing we just did. Because again, we don't want it to be the end of the buffer, so we gotta move it back 1, and then we also make sure that we have space for the null terminator, so we go back another 1, so that's 2. So let's go ahead and get rid of that. Attempt, let's say attempt to get buffer. Set data provided buffer. At end of, say attempt to append the const car pointer version of the integer. Attempt to append the const car pointer of the integer to the end of current string. Okay, and then here we're going to want to provide the actual type. So we're going to do t integer type. I just don't know if this looks good as a type though. This is usually more for like fields. That's usually what this is reserved for, in the t underscore thing. Or like m underscore is usually for like specific data. You know what? I'm gonna get rid of the t. Yeah, I'm gonna get rid of the t. Don't like it. Just realized I don't like it. This thing really is not linting at all. Let's see. Okay, and then this is garbage. Okay. So. If EC is equal to std error C, like a standard one, I guess. Is there like an equals 0 somewhere here that I'm missing? Let me see if there's like an overload or something for this type. Made for generic errors. I'm just gonna say, oh my god, this mouse thing is killing. What is it doing? Oh, it's because when I release it does that. It's annoying. If not EC. And then I'm gonna say else. Return. I'll just say if EC return false, right? So if EC return false. There we go. I think it's a little bit more readable. So if the error code is like something, then return false. Otherwise, go ahead and set the pointer. And then we need to set the length now. That's new length for data or C string or string. And then we're going to say and string length is equal to, what is it going to be equal to? I suppose I can do pointer minus that's right, or dot data, is that? This is an error type because I don't have the right includes for this. Where is SD2 cars defined? How do I use SD2 cars? Yep. So, okay, it's used here. Sure. Oh my god, my mouse. Stop. Ugh. Okay, I need to buy a new mouse. This is getting ridiculous. Okay, so here, SD2 cars. If ooh, wait. So this looks like it's fine actually. So it does SD2 cars and it goes for the buffer, and then it goes buffer plus size of buffer, and then it looks like it handles it well that way. So then I might only have to do -1 then instead of -2, because I still need to do a -1 for the how do I say, for the null terminator, but other than that, okay, sure. Buffer int value 1 2 3 4 5 pointer. So contains let's say, can I use the code if EC, and then and true. Yes. This whether check is a type which can be evaluated in a Boolean context, which is if I was to false, otherwise it returns to true. Okay, I was making sure I just wasn't making weird assumptions about that. So yeah, I just like how this reads better. So yeah, I think that's good. Oh yeah, and then how do I get the new length of the buffer? Buffer using the return pointer. I already have an idea on how to do this, but I just want to make sure ChatGPT agrees with me. And pass the length. buffer. Okay, I'm assuming this means like buffer evaluates down to a pointer in this case, and then we just pointer minus buffer. What if I am using an std array as the buffer? How would that look? I'm the same, but it needs to dot data. Okay, that's what I thought. Yeah. Okay. Just making sure I was right about that one. So yeah, that should be fine. You say, and then set the new null terminator for the string for the string. Ensure only integer types are used with this function. I should really read up more on these things, but that's fine. Yeah, we just attempt to append, and then if it works, I mean, I suppose I could log it if it fails, because right now I'm kind of just silently failing. Or I could just handle that in the code that I write. Yeah. Okay. I think I like that. Yes, the default length is this. Okay. So this code is actually going to be pretty similar to this code. So maybe I should make a function out of this. Be like privates. Let's see what's going on. Why is it like that? There we go. I guess I'll return a bool. Assign replace buffer. I'll do inline bool. Should I name a function? Should I name a function inline? Not name. Should I add the keyword inline to a function? I want it to be evaluated inline evaluated at that point in evaluated, I guess evaluated inline inside when inline by the compiler when it is used. It's just going to be inline, but it does not force the compiler to inline it. Have to earn a favor for. It's usually better at deciding when that function should be inline or not to avoid multiple definitions. Yeah, I mean, I know that's the normal usage of inline, but It can lead to increased code size without clear performance benefits. I guess so. Alright, well. Alright, Mr. Compiler. I guess I'll start arguing with the compiler if I really start having performance issues. But, yeah. We're just moving over pointer, so that should be not too bad. Turn through, right? So this still does all the things it needs to do. But here we just call replace buffer. New string, fill a pointer, so that should be fine. And then return the dereference to this. Put it to do. Maybe alert and fails. Maybe, I don't know. Add new null terminator. Okay, so when you pass it over here, it'll just do all the work for you. So here, I'll just do, instead of in the code, I'll just do replace buffer with new string. There we go. Because, yeah, it's the exact same code. Let's say internal functionality, I guess, until I find a better description for it. Okay, so now you can append. You can append an integer. C style, replace buffer. Yeah, I'd rather keep it consistent. Okay. I was just thinking about my naming schemes real quick, but I think it's fine. Okay. So I think I'm like somewhat satisfied with this. So let me go ahead and test this out really quick, and then I'll move on from there. I may also want to like add some specializations to this. So I might want to have like a class wait, do I want to specialize this? Never mind. Adding polymorphism is just gonna make it all messy. It's already complicated enough with the template. Alright, let me head back over to testing. Okay, and I gotta remember not to be clicking straight in the air. Let me go to testing panel. See, this is where I probably use like adding unit tests. For like a class like this, like a newly written string function, a string class. Anyways, let's see. Let me go ahead and add like a static. What do I want to add? What do I want to add? Static. Let me add the fixed string to base. So I'm gonna go to base.h. And let's go down here. Yeah. Oregano core fixed string. It's gonna make the whole engine recompile. Whatever. So static fixed string, say 32, just 64. String. New string. New string is equal to Actually, let me bring this definition up and put it. Let's put it up here in the empty scope. And then say new string is equal to and then let's do kg warn, and then let's do string dot c string. There we go. All right, I'll be right back. It's getting cold, man. Okay. Yeah, let's see what's wrong. It says attempt to append the const car. Okay, so m data buffer dot size plus string length. So that'd be the start of it. Data plus size -1. So it provides the full buffer as an option. -1 for the thing. One thing I could do also is just do buffer size. Yeah, because it's string length to buffer size -1 for the null terminator, and then spec widget. What am I doing? Yeah, I didn't finish the definition when I talked. Integer. And integer. In integer. I guess appendage. I don't know, whatever. Yeah, of course it failed. I left a bunch of code in there. Out if exits if appending fails. Okay, let's try that again. Oh, I don't know what mdata is. True. Yeah, maybe the linter was working. Mdata buffer. Mdata buffer. Okay. Any other locations for? Oh, he doesn't know because I have the T in there. What else? Okay. Looks like it's mostly those. Let's try it again. Okay. Replace buffer. Sure. Alright, looks like it's compiling now. Good. Those are the normal warnings. I need to figure out how to deal with that. I should take a good look through EP reference one of these days. Just kind of peruse what different things I have available. What is locale? I remember he was telling me about this. Object of class as you look at is an immutable index. Set of immutable facets. Each stream object on C++ associated with an SD locale object and uses its facets for parsing and formatting of data. The locale is associated with each SD. Okay. As if it's a locale name string. Oh, So text processing libraries. Regular expressions. Expressions which are kind of mini language used to perform strings on the song operators with vectors for offering. Two ternators. An alternative. Okay, so I can do an alternative character string or a SD string also. Nice. It's like most of the things that I want to work should still work since I'm using, I can just provide C strings for them. Exceptions, basic stack trace, debugging support. Oh, that's 23. I don't have 23. Expected. What is that? Res a way to represent that value is expected value to or an unexpected value E. Yeah, that's kind of annoying. I mean, I can see that being useful, but I don't know. I don't like that. Comparison, utility. Calendar, time zone, print functions. Okay. Okay. That looks like it's working. So now let's try to mess with it. Test panel. Like a button or something? Editor UI. Editor UI. No, I don't think I've added like a button API. Probably should do that at some point. Okay, well, I guess I'll just use a regular button. If I'm GUI. What? Oh. Are you cheesing, Tom? So a new string that's append. AG1. I'll say I'll just this, so I'll probably return like a 1 or 0, I believe. Add if let's do another one. GUI button. Show string. And then we're just gonna show the string. So then we can add them. What else? Add numbers. I think I have a random API. Let's see. Random? Is this provided to me? Wait. Yeah, where's my random API? I always forget where I put that. Oregano utility random. There we go. Random utility random service. And what can I do? Generate that number. And then how do I generate? Lower bound, upper bound. Sure. So we do, it's int 32, so I'll go from 0 to like 2 billion, I guess. I think I can do, right? That's allowed, right? The literals. Yeah. So it's 2 million. I guess that's fine. Add a random number. Random number. Append integer. Let's do this. So this will just return whether like it like worked or not, right? So show string. I probably also want to add like maybe one more thing. Let me go to fixed string. How about modify string? How about void clear string? So then basically we just want to I mean, you don't really need to do much, honestly. You can just go here, set the beginning value to null terminator, right? Just do it at 0. I think also maybe I'll add a static assert just to be clear, because I mean, I don't think I would ever do it, but that would be a weird edge case if like for some reason I set the buffer to 0. Crash some things. So static assert buffer size is greater than 0. What's wrong? What do you mean? Okay. Scan create empty fixed string. Or no, essentially fixed string with empty buffer. There we go. Because yeah, then this logic will fall apart if I try to set it to 0. So now, yeah, I don't have to worry about that. When mdata buffer 0 is equal to, how do I say? Yeah, just set the first object to null pointer and then set the m string length to 0. I think that's it, because I mean, I don't really care what else is in the buffer, honestly, as long as the null terminator starts there. That's basically what an empty string is. Okay. So we'll add another button now. We'll call this clear string. Let's see, new string dot clear string. It's a void, doesn't return anything. And then ag1. New string dot c string. Nope. U string. Okay, let's try that. It's really quick. So yeah, once this is done, I'll get back to messing with the content browser. What's wrong? Additional is not valid. What? We were fine before. What happened? It is not valid. Requires an explicit cast to a boolean. Oh, I didn't know that. ChatGPT was lying to me then. Okay, well. I think it's is cars something cars. What was it doing? SCD to cars. That's what it was. There it is. All right. So how do you guys handle this again? So if result yeah, you know, I like this better. So first thing is this. Yeah. So yeah, if there is an error code, then write an error code. Otherwise, we're gonna like what is it called? Write this out. We're using a string view here. String. Let's look at string views as well. To the beginning, to the end. Basic string view describes an object that can refer to a constant and contiguous sequence of car T with the first element of the sequence at position 0. String pointers and references to the string are invalidated when an operation turned in the range of data to a size. Refers a pointer to the const car and a size. Okay, so you can like easily get like a substring from it. Yeah, I suppose not too bad. Let me see the usages of a string view. So string view of Unicode, whatever is going on there. Or Okay. Okay, sure. Yeah, why not? Okay, let me go back to what I was doing. I just got lost in reading about string views. I probably will use that soon. Alright, so I want to get this instead. Mouse, stop doing that. There we go. Yeah, I'm gonna go to the store so I can get a new mouse. It's getting really annoying. Oh my god. Yeah, there we go. Requires results. Right. Results. Result.exe is equal to not equal to that. And then now results.pointer and results pointer. Yeah, that's fine. Okay. I think that's good. Try that out. Probably because I'm trying to dereference here, and it's like, yeah, sure. So yeah, it needs that. Probably. Anything else? Is it just that? Okay, looks like it's just that. I'll try that again. should do something really quick. What are some typical sizes for fixed string buffers for different applications? The 256. Okay. Okay. I suppose so, yeah. What happened? What? Not valid as right operand has type car pointer. Wait, what? Not valid as left operand. Wait, what? This is not working. What's code? Yeah, there is missing semicolon there. Use independent buffer, the resulting string will be netted by default. Yeah, I already checked for that. We talked about it. Because if it wasn't successful, yeah, if it's not successful, I just exit. If it was successful, then I add null terminator. So, oh, I never returned true actually. The linter's just not working here. see. Where we at? Okay, there we go. Finally, some compilation. All right, so let's what happened? Okay, that's weird. It's like the testing window just gave up for some reason. Okay. Right. Clear string. Okay, we added a number. So it looks like the number we added was 64214. Add a fam. Okay, we added fam. Another fam. Clear string. Add our own number. One number. Okay, I'm gonna keep going until it fails. Oh yeah, serious. So there we go. So now add another random number. It's gonna keep failing. Go and clear the string. Add a fam. Another fam. There we go. Okay. Clear string. Alright, it looks like that's working. So yeah, clear string's working because it just sets it to null and then yeah, easy as that. Yeah, it's just false. And it just stays the same. Then we clear it. And just add your fams. Okay, that's good. I mean, I don't see any issues. So looks like the string class is working. As I need more features, I'll just go ahead and add them at that time. Ooh, but yeah, I think that's good for string class. Let me continue with the content browser. Let's go ahead and see what I was doing there. I can go ahead and replace this, whatever I was doing inside the editor. Yeah, all this. So instead of this, what we're going to do is we're just going to do a fixed string of size 60. We're going to call it ID. And we're going to initialize it with this. Okay. Then we're going to do ID dot. No. Yeah, ID dot. Oh, because it's okay. Yeah. So it's referring to two different things. Let me go ahead and comment this out for a second. And then we'll do ID dot end integer. The integer is going to expect that widget ID. There we go. And that template should just deal with it. And then ID dot C string. There we go. Okay, so all this code now is just these two. Way easier to read. I don't think I use it anywhere else, so let's go ahead and try that. And I'll go ahead and replace the rest of the API with this. might add some using definitions maybe. So, first string. Okay, well, I'm sure it's fine right now. So let's go ahead and exit really quick. And let's try it. Let's try this out on some other ones really quick. Do I even use widget count here? I don't think I do. Kind of want to implement like an FMT type of thing with my fixed string. So let me see if I can do something like that. I'm gonna fix string really quick. Yeah, I hope ChatGPT doesn't freak out when I add this many characters to it. How can I add an FMT style API to my string class? Here is the class. And then I'll go ahead and research it for a bit. You could create a formatting function that accepts a format string and a variadic argument, just similar to FMT. Okay, this function can use integrate it with the existing. Just a lot of stuff, yeah. Okay, so we do a const char format string, and then we have a template arguments, right? And then use a temporary buffer for formatting, sure. So this is and it just sets it to this. So sn printf. So we set it, okay, so we create a temporary buffer. Interesting. Int result. Formatting failed. Let me see. So do I need the temporary buffer? Do I need the temporary buffer? Can I just check if the call to send? It seems like a waste of like adding a whole buffer with the exact same size just to drop it. I mean, if I guess if I have to, I have to, but still, I don't know. Greater than or equal to size to your results. Or is SN printf like an unmanaged thing? Printf. Can I just check if they're called SN? Works. carefully check the results and handle them. You need to ensure that your internal buffer has enough space for the formatted string, including the null terminator. So just do like a prior check. So check the required size. If engine fails or exceeds is less than 0 or exceeds buffer size, return false. Otherwise, just update the string length. Attempts to write directly into if it returns a value that's negative or greater than or equal to, as long as it indicates an error or that the output is truncated. I think this is set to m string length. Okay, let me see exactly what this function does. So std print f, std f print f, s print. And writes the results. Result to a variety of syncs. Writes the results to std out. To a file stream, writes the results. So these all format text, these all require a format. But then they just write out the different things. So to a character string buffer, then write the results to a character string buffer and most buffer. Resulting character string will be terminated with a null character unless size is 0. Okay, so this one handles the null termination itself. Buffer size is 0, nothing is written, buffer may be. Interesting. Okay. Okay. SN print F. Loads the data from the given and converts them to a character string equivalent and writes the results to a variety of syncs. String will be terminated with a null character unless buffer size is 0. 0, nothing is written. Buffer may be a null pointer. However, the return value is calculated and returned. Okay. So I definitely will use this one. This is defined in cstd.io. So let's head up here. Hash include cstd.io. Okay. I'll do void set string. Replace buffer string. Okay, so there's multiple ways to do this. You can do an overload or you can just do this. And I'm gonna do a const var pointer, new string, right? So you can clear the string, you can set the string if you want. Let's see, set string format. I'll just say set format. And then what we want is the format. So in this case, we just want the const card pointer of the format, and then the variadic function. So, and then I think in ChatGPT they said something about. Let me see how they define this. Yeah, it was something like this. So, template with like variadic arguments. I never loved these, but I guess it is what it is. And oh my god, my mouse, stop it. Thank you. Okay, there we go. Put it below, actually. Okay. Comment it out for a second. I do want the arguments. I'll call it variadic args. Yeah, we'll do a bool, I guess, format. And then we want a const format string. And then variadic args. And r value reference. That's args. Okay. How do I use and create std error codes in my code base? I might want to start using these, I don't know. It's a lightweight representation of an error that allows for flexible error handling. You can create and use std error code for your own error types by defining custom error categories. Here's a comprehensive guide. Okay. Include the required header. First, ensure include the necessary header, std error. Creating a necessary error code you can create from predefined error code or your custom category. Define error category by subclassing. Here you'll do it. Do I want to bother writing these error codes? Make error code. Yeah, I suppose. I'll just put a comment up here. This function may truncate if note that this function may truncate the provided formatted, the resulting formatted string if the buffer is too small. Okay, and then basically how I'll handle it is I'm just going to like attempt to use snf print directly on the buffer, and then if the buffer size is greater than like our current buffer size, I'll just return like a warning saying that. Let me think. I won't even return a warning. It'll just get truncated. So it might just error out quietly. I might want to start using error codes at some point, but I don't think I'm gonna bother here. So if it doesn't work, then it doesn't work. Like if the size returned is less than 0, then I know, okay, like it didn't work, right? So I'll return false. But otherwise, if the size is greater than the buffer size, then, I mean, it did work. It did replace the buffer, but it just got truncated. So like, it kind of just is what it is, you know? You just, like messed it up, I guess. Something like this. So I just don't like using these ints. Query size. And then m data buffer, not data, right? So we want the pointer, then we want the size of the actual buffer, right? And then format string. So the actual like format string, right? And then we just push along the arguments, which I don't know if I need to add like a include for these. I might. Let me see. Here is formats. Something my cat's crying. Hold on. I'll be right back. Let's see. In C++, it's a lightweight representation of error. Okay, I know. Okay, let me hit back. Okay. Yeah, this is what I want. I want to check the format thing. So again, we take the buffer pointer, the size of the buffer, the format, and then we pass along the args. I don't know if I need limits C int types. I don't think I need those. So yeah, format, and then the remainder of the arguments. So yeah, that looks fine. And then what we're gonna do is basically this. I mean, oh my god, this mouse stopped it. Okay, there we go. Okay. Is less than 0. I'm not going to worry about it being bigger than the buffer size. We'll just return false. I don't want these inline things here. Fails, return false. Result. Get resultant size of buffer. And then, yeah, it just sets it to the new size, right? Return true, and then we just want to update the size. Ring length is equal to required size. Let me rename this and do new string size. Oh, yeah, I'm gonna erase this. I don't care. Just make sure I don't want it to go out inside of scope. There we go. Okay. So I'm gonna say replace buffer data inside buffer with formatted string and get resultant size of buffer. Fails, return false. And then if success, update string length and return. I'll just say update string length. And then obviously return. Returns if the first too small. So I'll keep this note here, and then like if I need to come back and add another version that doesn't quietly error out with that, then I'll go ahead and add that later. But this way I can add it, I can just set this string to like a format easily. And let me see. Also note that SN printf deals with null termination automatically. I figured I'd just put that there just so that I know, because I might come back here and be like, where's the null termination? What am I doing? Yeah. So yeah. Maybe I'll put this up top of the notes. Okay, so I think this is fine. So now I have a way of like setting the format. Yeah, this only returns false, so like it straight up just does not work. But otherwise it sets true if I actually like modify the buffer. So yeah, I think we're good. Now we can set a format, which is nice. I think below this, what I'm gonna do is I'm just gonna provide a few like using definitions. So like using fixed string 64 is equal to like fixed string 64. There we go. So this way you don't have to, like, these will be like ones that I could just use like typically. And then like I don't have to worry about the templating thing if I just want to use like a standard one that I agree on and that I like. Let me go back to that chart again and see. I think it was somewhere up here. Oh, I like that chart that ChatGPT gave to me. I probably will have to give like custom amounts if I want to be efficient in some cases, but I think for the most part I'll probably use like, yeah, here we go, like just standard amounts. Let me just copy this for a second. Okay. So I'll just use the upper bounds of these. So 32 for status codes, integers, etc. Hash if 0, hash and if. There we go. What is wrong? May not have a template argument list. What are you talking about? Cardano fixed string may not have a template argument list. Okay, I don't know what it's talking about. But anyways. 64 for like for usernames, UUIDs, and small formatted strings. 64. Yeah, 64. It's 32. Okay, now it isn't. Now it's come out of me. Sure. So then I'll do 256. 256. And then I'll say for usernames, ports, log messages, etc. Okay. And then I'll say 1024. 2024. Long file path. Full log messages. There. $8,192. $8,192. Actually, for all these, I'm gonna put generally, and I'll do 4, and then do this, just so I don't have to keep like going back online and like searching things and being like, oh, is this the right payload size for this? Like, is this appropriate? And then, you know, so, it's 2 for generally for HTTP headers, small payloads, networking, so like small socket payloads, etc. And this one I'm gonna do 64 KB. And then whatever that is, I guess. What is 64 KB in bytes? Is it really? Oh, okay, cool. For, I mean, I already have buffers for these types of things, but you never know. Large data stream or file. Okay. Cool. So now I can use these predefined ones for like whatever scenarios. And then yeah, if I just want to use one that like I generally want to like provide, like I think if I want to provide like distinct string lengths to like my engine API, I probably will provide these, or maybe add a few more. I don't know. Just so yeah, format looks good. I'll go ahead and get rid of this. Append integer. Yeah, set substring I'm not gonna do right now. I'll just do maybe add append substring. and delete back functions. But I'll do those later. It's not exactly necessary right now. So here we go. All right, let's head back to what I was doing. Let me test out these formatted things really quick. So we'll do add formatted strings. So instead of this, we're gonna do. Oh, actually, no, we'll do it inside here so I can see if it's true or false. Okay, so let's try do new string dot set format. And the first thing we need to provide is a this blank is the new product you need at blank. Right. Okay. This washer at the price of $3.99. String. This is a pretty long thing, so I'm gonna up the buffer. Oh yeah, and actually, you know, I can try out this new thing. So I do fixed string. I'll do 256 this time. And I can try this out. What? Args. What's going on? Unexpected return following expression because I didn't add the semicolon. Because the linter doesn't like me right now. Args. Args is not a thing, I guess. Oh, yeah, because, yeah. I called it variadic args. There we go. Okay. It's looking good. Integer. There we go. Yeah, I guess this really was the add strings class, add strings stream. Saying string length, just I guess it's like an implementation thing. Oh, constar, string length, size t, c decal, string length. I cannot read these. Whatever's going on here. Okay, well, anyways, let's try it out. So let's take this, bring it over here. Let's do this. Let's go ahead and clear the string. Add formatted string. This blank is the new product. Okay, so I think the format uses that like percent thing then. Let's go to the testing panel. Testing panel. I always forget semantics for these types of things. I don't usually use these that much. Okay, so I think it's what is it again? It's like percent percent s. Is that how you do a string? Percent f or float or floats, I guess. If you want to write a string, something c. Oh, it's like for a character. Okay, so for these are all integers, sure. If I want to output it as hexadecimal, I use this, I suppose. Output octal, okay, sure. Floating points, round. Let's put string, so percent 10s minus 10s. Oh, that's the like where it gets placed in the thing, sure, around the format. I got you. Like plus spacing, yeah. But yeah, I'm assuming just s will. But oh, was I not compiling? I thought I was compiling. Okay, so let's go ahead and look at this really quick and do this for this one. Yeah, so we're gonna clear the string, show string, add random number, and then replace it with the formatted. Okay, this washer is the new product you need at 399. Okay, there we go. So that works. Cool. All right, so now I can kind of use this however I want. Nice. And then I can just append fam at the end of it, I guess. And then this is a pretty big buffer, so I can just keep going, I guess. All right. Maybe I'll add another one for like append format. Set formats. And maybe like append format. Append. Right. So we just do data plus what is it? String length, I think. Format, and then the second part, and then buffer size, right? Oh, it's buffer size. Okay, I gotta be careful with this because this is this plus the remaining buffer size. So it's buffer size minus and string length. Right. Because the beginning of the buffer is going to be wherever the null terminator is, right? And then we just want from, how do I say, from the null terminator to the end of the buffer. So we can literally just like remove that beginning part of the string, and then that remaining size will be the actual buffer that we can actually work with. Yo, what's up? I'm just doing some string stuff right now. Someone came into the stream while I'm doing like bug fixes and stuff, and then someone came into the stream was like, why are you using SSD string everywhere? What's up with all those heap allocations? And I was like, yeah. So now I'm dealing with that. Let's see. Append format. Okay, so I think this should be fine. So this starts at the end of the current buffer, and then we get the remaining length of the buffer. Still the same format string, it's still the same args, so we're good. If it fails, then we return false, that's the same. If success, we update the string length. A string length is now our current string length plus the new string size. That's what newly got added. And I don't need to deal with null terminators, I don't need to deal with any of that. So I think that's good. Yeah, so basically like so like SSDs, it's so like, how do I say, let me go over to where I'm doing my testing. Okay, I think I'm done with this, so let me head back. Testing. So the thing is, right, like I'll try to do a quick explanation of it. Whenever you use like SSD string, right, when you actually go in and look at the string itself, like wherever the actual definition of it is, I don't know. If you actually look at it, the actual like values, you have like the size, and then you have a pointer to like wherever the like data is, right? But that pointer is allocated in the heap, right? Not on the stack, right? And then the good thing about putting it on the heap is that you can make the string as big as you want, and it won't matter. It'll just keep reallocating. So like say if you like are writing like text, and then you just keep adding more and more text, you'll reach the end of the current buffer, and then we'll just reallocate a new chunk of data inside the heap, which will like give you a bigger buffer, which is really cool. You know, it's really like dynamic, and if you just need like dynamic like text to just work, just use a string. Like, it's the easiest thing you can deal with, right? yeah, the stack is always faster, right? Because whenever you have stack allocated memory, you push the stack on for a new like function, right? And then that memory on the stack is like immediately available to like your CPU, because it's like right there. The heap, basically you have to like follow a pointer into the heap, grab that data, and then you can use it. And it's fine if you're only using it like a certain amount of times, or like that reference is like in the buffer, like, how do I say? Like if you're using that same string a bunch of times over and over again, it's fine, right? But if you have like 1,000 strings or 10,000 strings like strewn about your application in just like random places, right? That's really bad, because every time you want to allocate any of those strings, there's like a layer of indirection, which slows down and also just grabbing things from the heap is also always slower than grabbing things from the stack. So it's like a double fold, like bad. Let me see. The stack is faster. I assume that. So why you want to? So yeah, the thing is, the stack is harder to like modify, right? But because it's like a fixed length data, right? So like you need to know like how big your string is going to be if you want to have like a fixed length string, or if you want to use fixed length strings, you have to know in advance what's like your max buffer size, right? So that's the issue. Yeah, but if you can like, if you do know that you're not going to go above a certain size, it's always the best like scenario for like performance. So that's where like the case by case like situational like basis thing comes out. It's like if you know your requirements, then you can always make it faster and optimize it. But if you don't know your requirements and you're just trying to like get things to work, you can just use a string. But the moment your like application starts actually doing a bunch of hard work and you're like, oh, what's going on? And then you want to like come back and be like, okay, I guess I can't use strings. So yeah, guy came in and was like telling me about that, and I was like, oh, I don't want to go through my whole application and start fixing strings, because I use strings literally everywhere. But the more I thought about it, the more I was like, no, you're making a good point, because if I don't start dealing with this now, I'm just making the problem worse and worse, and I do need to deal with it at some point. So let's see. Also, is stack memory. I'm thinking anti-cheating for my game, for instance. If I use stack allocation instead of referencing a lot of stuff, the heap will be harder to change. People wanting to cheat. If you use stack allocation instead of referencing. I'm just thinking about your question. Let me see. I'm thinking. Will that be harder to change from people wanting to cheat? Will that be harder? Yeah, I mean, as far as like, if people want to like, because I'm assuming what you're talking about is like people who do cheating, they like go through the binary and like locate the area in memory that they want to change so that they can like change their score or like start doing like hacks, right? Yeah, like they use a cheat engine and that can like identify the locations in memory and then change it. Like I know what you mean. Basically, using the heap versus the stack doesn't actually change anything. Like they can still find that memory, and like because like the memory that you gain from the heap, you're asking the OS to like give you like a chunk of memory. But the thing is, you're not like asking for that chunk of memory every single time you're doing a heap allocation. Basically, from my understanding, is that like the OS, like when you start up your application, when you do your first like heap allocation, the C++ standard will grab a big chunk of memory from the OS. It'll over allocate. It'll say, hey, give me like this big chunk from like the OS, and the OS will be like, all right, here you go, right? And then from there, basically, as you do more heap allocations, like as you like add more strings or add just different things that you like add on the heap, your program will first go to that buffer that it got from the OS and like allocate from that first. And then once it runs out of memory there, then it'll ask the OS again, hey, give me another big chunk, right? But that chunk that it grabbed from the OS is still kind of like yours for now. Like it's like, once you grab it, it's part of your memory. So whether that memory exists inside the heap or in the stack, it's still part of your program, right? Yeah, so like whether that would affect like anti-cheating thing, basically it wouldn't matter. The cheating engine would still be able to find the memory. Because yeah, they both exist under the domain of your application, as far as my understanding goes. Yeah, I mean, I don't know. I mean, I appreciate it. I just know the things I know from like working on the thing. That's it. The guy who came into the stream was telling me about these things. He was telling me all these like things about strings, and I was like, bro, I have no idea what's going on. I gotta take a second to figure this out. Because I really hate strings. Do I want to say my exact age? I'm in my like late 20s. Ooh. Let me see. Yeah, I feel like the age doesn't matter. It's about like what you know and what you can do. But yeah. Anyways, let me see. What was I doing? Okay, so I was testing out these string things. I think it should work. So that, and oh yeah, I was trying to see if I could append a formatted string. So let me go ahead and add another one. And after this, I can actually go back to what I was actually doing on stream. Let's try 6.99. Washer. Pretzels. Okay, so this one should append, not set it. So let me try that. You said AI? What do you mean? Dun, 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 dun. Oh, yeah. So actually, I finished AI. What is it? Well, not finished. Like, there's still a million things I need to do with it. But I finished it to the point where, like, the next thing to do is to start working on, like, game levels. And then, like, per game level, I can figure out, like, what is most appropriate for, like, each AI. You know what I'm saying? So, like, I can do more, like, designer type things. But as far as, like, the actual functionality that I need from the AI, like from the Pong, that's done. So, yeah. So right now I'm doing a lot of like while I was doing the AI, I was ignoring a lot of bugs because I just wanted to get AI working. So now I'm like dealing with the bugs. So I might be doing this for a few streams. So just kind of boring stuff. I do plan on making like a YouTube video also like covering the AI. So hopefully I can have more of a succinct like coverage of like what I did, because I know not everyone wants to see like 30 hours of just like me coding AI. So hopefully I can get that done like this or next week. Honestly, I kind of suck with video editing, so we will see. But I appreciate the interest, man. Appreciate you coming by. Real quick, I drank a whole bunch of coffee. I'm gonna go use the restroom real quick. Kitty, when did you get in here? Oh wait! I gotta move the bed. You gonna pee in my bed? Oof. No. No peeing in my. Washing your ass. Mau. Alright, I'm back. Let me check if this thing works. I just read a technical code. Honestly, I'm not sure either. I mean, I just know like yeah, there's like certain ways of like doing anti-cheat. Like there's ways of like detecting when people cheat. Yeah, I don't know enough about the topic to like give you like a good answer for these types of things. Because you can do like traps where like you can like check if someone is messing with the data, right? Typically, when you're doing anti-cheat, and if you're like doing like a network game, you want to do like server-side validation rather than client-side, because obviously the client with the cheat engine has access to the entire code base. So like if they find a way to like deal with like your tests, then like, yeah, it's useless. I don't know if there's a good way to like mess with, like get anti-cheat working with like a client-side application, especially like a single player game. That, yeah, it's out of my domain. Yeah, like it's like, yeah, how do I say it? It's kind of like obfuscating, like, how do I say? I don't know. It's kind of like those people who like when they build out like security for like their web applications, they'll put the admin page as like a random URL like on the web page instead of like actually putting security for it. So like the security there is like not actually security, it's just like hard for people to find the URL, but like there are ways to find it. So it's kind of like that. It's like I don't know, like I feel like a lot of the solutions I see people talk about is like, yeah, like that will help like prevent people from like breaking the like validation layers you added, but like I feel like at some point it is always still gonna be breakable, especially if someone like has access to it. I mean, unless you do like cryptography maybe, but I don't know. Right, just but then you still have to load it into memory, right? So they could just pull the data straight from like the runtime memory and then, you know, fuck all, I guess. I don't know. Just memory addresses, right? But again, like I think a lot of those like cheat engines, like they have cheat engines where like they're able to like rebuild some of the binary from like those from the way like the like application works and whatnot. So like it's like it does the thing for sure. Like it's harder for people to read, but I still feel like it's crackable for sure. Or maybe that's the wrong word, but yeah, I don't know. I'll deal with that issue when I get there for my stuff, so. Or maybe just hire some security expert. This is gonna make money, I don't know. Add random number. There we go. So append formatted text. Okay, here we go. So 649, and then it appends the text, good. And then append fam. Append another random number. and then clear the string, show strings empty, random number, random number. Sick. Well, I mean, if I'm providing tools to like make a game, I might as well provide tools for like anti-cheat as well, right, at some point. But again, I'm making Pong. Like, does it need anti-cheat? I don't think so. Oh my god, they're cheating in my Pong game. Oh, what will I do? Yeah, it's fine. But I suppose if I got more serious, I'd have to start thinking about those things. Go murder, right? Okay, cool. So I confirmed that this works. I'm gonna get rid of this. So yeah, that whole string thing was like a big detour from what I was actually doing. Let me get back to what I was actually doing. Editor UI. So where is my editor UI? Surface, here it is. Grid. Yeah, this one. Okay. So basically right now I'm like, I have code for my content browser. But the content browser code is written directly in IMGUI, which it's fine. I don't love, because I feel like it makes the code base look really messy. It's just hard to reason about as well. Because, like, I don't know, like, how are you supposed to... Yeah, I don't know. So basically what I'm trying to do is I'm trying to, like, abstract out all of the IMGUI code into, like, their own widgets. And then once I have that, I'm going to bring the functionality back in. Like I'm going to replace all this code with, like, my own, how do I say? My own widget. And then all of the, like, content browser specific logic will stay in here. If that makes sense. So I've already replaced this part, and right now I'm trying to get, like, a new thing for this part. Or, like, a new widget for, like, this kind of, like, grid layout thing. So let me check my testing really quick. So yeah, basically, like, this is, like, the same thing as here, but it's my own widget. Instead of this is, like, directly written in MGUI. So I'm gonna test out this grid layout real quick. So I think I got the columns. Yeah, I think I already wrote the whole thing, so let me go back to grid. Yeah, this should work. So let me get rid of this. So push ID columns, push. So entry.label.cstring. Yeah, see, this is using strings, but I'm not going to worry about it right now. Push style color image button with the appropriate thumbnail size, sure. Text wrapped next column pop ID. Okay. And the ID is the label for each one. And I'm assuming... Okay, so this is assuming that each ID is like unique. But they might not necessarily be, so that's an issue I need to deal with. So maybe instead what I'll do is find a way to, like, add this here. Oh, for sure, for sure. Appreciate it, yeah. Yeah, I kind of figured, like, I mean, I don't know, I could have just went straight in for, like, working on the, working straight on, like, engine features, but I was like, I want it to look good first so I can, like, show people. Because I feel like everyone uses just the standard IMGUI, like, look, and that's fine, but I don't know. Okay, so ID. Okay, so I gotta increment the ID. Where is this? I'm gonna find an example where I do it. Do I really not have one? Oh, here it is. Yeah, widget count. That's what I wanted. And I think for this widget count, if I can find where I use it. Here we go. So you have like a function that iterates it, I guess. Is it, wait, really? Okay, I guess. So I iterate it and then I provide it. And then that becomes the ID, sure. So let's see. So I'm gonna do widget count first. I think for each ID, instead of providing this label thing, I'm gonna provide, it takes in a C string, doesn't it? Yeah, it does. Okay, let's see. Let's provide these labels as C string, but I want to actually generate each one first. So I'm gonna do a fixed string. I'll say entry ID. And then allocate it with ID. And then I'll do entry ID dot append. Append integer. And then I'll do widget counts. And then I want to increment widget. Wait, what did it? No, I forgot. Widget counts. Slide previous. Oh yeah, it's widget iterator. That's what it was. I think ID recommended automatic shading compilation unless it's already done. Not done it as far as solo loading lots of shaders. Yeah. So what is it? So I mean, so far I pre-compile all my shaders, but I don't have any like complex meshes yet, so I can't say how that's gonna end up looking. I do have like how do I say? I have like a shader builder, right? So I don't build individual like shaders. Basically, I have like what do I even call that? Like, wait, let me real quick finish this up before I go on my little tangent. Iterator for widget counts. So append integer to this one, and then instead of doing this, I'm going to provide this to C string. Entry.C string. ID.C string. There we go. And that should work. So now this should provide like a unique ID for each element. There we go. And if I do hash, yeah, okay. So basically for my shaders, right? Let me go check. Actually, maybe I can look at the folder that I do this at. Where's my renderer? So I have like a shader class, which like shield your eyes because it's disgusting. I kind of just threw everything together in the shader class. At some point, I'm gonna like kind of tease things out because I hate how this ended up looking. But anyways, like you generate one of these shaders, and you generate it using a shader specification, right? And the spec basically just has like I wrote this a long time ago, so it just has like flat booleans in here. And each boolean is like, okay, do you want to add a circle shape? Do you want to add a projection matrix? Do you want to add an entity ID? Do you want to add an outline? And then you can like mix and match. And then basically the shader builder will take in a specification, and then it will build out like a specific shader for that specific, how do I say? For that specific object, or that particular like, I mean, in my case, I just have quads and like basic primitive like shapes, like cubes and pyramids and whatever. So they all just use like a flat shader. So you would just attach that shader to that like object and then just like go about your day, right? And then like if I wanted to add new functionality to that shader, right, I just add it to the spec and then just provide that like new like definition. So it works like kind of like the shader builders they have in like Unity. Of course I don't have like a like a shader graph or anything where we can actually like interact with it in the UI. But yeah, the system needs a lot more refactoring. I wrote this like a long time ago, so. Well, I wrote the system because I was lazy. I don't because I really hate writing like a separate shader for every single thing. It annoyed the hell out of me. You know what I mean? Like, because I see some of the other people who like write their shaders and they write like each individual one, and they had like the same like boilerplate code for like the vertex shader and the fragment shader. You know what I'm saying? So like, if anything, this is just me being lazy. But yeah, I don't know how this is gonna end up looking like in the UI. I'm imagining it's gonna be like I still want to like mess with the shader code directly. I don't really care for adding the shader graph stuff. I don't know, for some reason I just don't like it. So, but I don't know what I want this to end up looking like later, so I'll see. But yeah, I'll definitely pre-compile the shaders before I start the game, because yeah, that issue they have in those games is really annoying, like compiling shaders. I get why they do it, but I don't know. I also don't want to prejudge too much too, because I know they probably went through like a lot of requirements that ended up that way too, so. Columns, okay, so I think this should work. Let me test this out. This goes through each entry, and then in each entry, I just have a label and an icon. So if I go over to my testing panel, okay, so let's do a static one. Actually, do I want? It's not gonna matter. It's a testing thing, anyways. Editor UI grid back. Test grid. Grid. Something like that. Are there any relevant flags? I kind of forgot. Allow drag drop. Yeah, I don't want to allow that right now. Test grid dots. So I think padding and thumbnail size have like default values, if I'm not mistaken. Yeah, so I don't have to mess with it. So the last thing really is just to do test grid dots. Oh, I need to be able to mess. Okay, that's the one thing I forgot to do. So I have this vector, but I can't like interact with the vector. Maybe I'll just provide it, because I'm trying to do struct, like a struct type of thing. Wait, actually, do I? No, you know what? No, I want to provide an API for this. So public add entry. Let's see. Let's take an input entry reference. Do you want to do R value? It probably would be more efficient to just do it in place. Oh, actually, this is a good place for me to use my new API now that I think about it. So now I can use a fixed string. And what's the maximum length I want to do for this? it's a label. Let me check what I said. For status codes, for usernames, for other usernames. This is way too big. I'll do 64. Let's do 64. So label. And actually, I gotta remember now. From now on, I want to start using the new. I'll do a pass at some point. This, but the new way I want to do this. Brain work. Do I want to provide an R value reference? You know what? Yeah. New entry. And all I have to do is just entries dot. I remember someone talking about in place and like why I should use in place instead of using pushback. Let me see. I never understood that though. Using in place versus pushback with std move. It's when you want to move an existing object into your vector, when you want to create a new temporary object. Instead of creating that temporary object past the... What? I think that's topic. It's better for performance, yeah. Using in-place back comes from administrator when I look in, see this written, okay. Add value. Forcing the realloc. Widget, R value reference. Okay. You have like a summary. Use pushback when you have an existing temporary object that you want to move into your SD vector. Originally use pushback when you want to move an existing object into your SD vector. Create a new temporary object instead of creating that temporary object past objects structure arguments directly to in-place-back. Oh, okay. So in-place-back creates that object directly in here. So that's why it's more efficient, because there's only one allocation of or construction of that object. And then placeback, usually if you already have that object available, then you would provide it. So that would be more along the lines of using SD move, I think. Maybe. I might be overthinking this, I don't know. Let me ask ChatGPT. Use the vector place push back versus the dot in place when providing an R value. We use takes a single argument. When you pass R value, it uses the move constructor. It will add requires that the object you're adding is already constructed. Okay. So yeah. So you know what? I'm gonna use pushback. Push back for this case. And then provide the new entry. I think I'll do SD move for this one. Let's see. Let me just just ask ChatGPT if it agrees with me. What do you think of this code? The code you prepped is generally correct in terms of transferring ownership of R value into. However, there are a couple of considerations to keep in mind. R value isn't allows you to pass R value references, which is appropriate if you're planning to move from this object. Using it ensures that you move the object into the vector rather than copy it is efficient. And I'm assuming that once they said that pushback should have an R value variant, which would recognize that I'm providing an R value. Okay, so how should I call this function to move its data into add entry? Oh, I could use SD forward, I guess, yeah. No, I don't want to use templates. What are you talking about? Okay, yeah, so you do use SD move here. That's what I thought. I'm gonna say I don't want to use templates. And I still use SD move. Okay. If you're not using templates and want to keep specific to, you can modify the R value directly. Okay, so yeah. All right, cool. So I do SD move on there. Okay, and then I'll say, okay, yeah. So const, if you want to do const reference, and this copies the L value over, and this one will move the R value. So I should probably provide both. Okay. You're right. So then if I don't want to use SD move, I could just use this. And then that should work. Const reference, pushback. Yeah, there's no, that's because this would be a lot of copies it's making. Oh, well, no. It's just making one copy here. This is just a reference. So that's fine. Okay, cool. Got stuck in move semantics for a bit. Okay. So now that I have this, another thing I want is void clear entries. Yeah, we just do entries not clear. All right. These are all stack allocated, or not stack. Well, they're on the heap, but they're not pointers, so that should be fine. If I can spell it right. There we go. The other thing is, do I have a remove entry? Yeah. It's a vector, so do I want to store it as a map? What's the most common use case? If I store it as a flat vector, I can just iterate through it every frame, which is the fastest. That's the most common use case. And then if I want to change it, it is going to be a bit slower. to modify it, but it's like an editor thing. Like, I don't care. Yeah, this is fine. Okay, I think this is all I need. So let me go back to test in the panel. Alright. Let's go here. Alright, and let's do a for loop. Let's see. So let's see, stp size t, iteration to 0. Iteration less than 5, iteration plus plus. For each iteration, I want to, how do I say? Test grid dots. Or actually, it's going to be editor UI, grid entry, new entry. It's equal to. I don't know. It doesn't matter. I'm testing it. New entry. Label. And this is a fixed. So I do new entry. Or actually, I don't know. So I'm assuming it's empty by default. Because it would have already been constructed. So I'm going to do dot set format. There we go. And then we want the format string to be new entry. And then I'm going to do a decimal maybe. It's like %d. I think it's I for integer. I for integer. And I'll do iteration. There we go. Okay, so that should, and then maybe I can start at 1 as less than 10, I guess. And then do new entry dot icon is equal to let me go ahead and get my icons. Where do I put them? Editor UI service s icon. Do display, I guess. I don't know. Whatever. And then we're going to do test grid dot add entry, and then we'll do sd move new entries, so we don't need to do anymore. And that way we only create this once, and then this member gets stolen. Nice. And then let's go ahead and draw it. Let's see if it looks good. So I'll do it after the header. Editor UI service, and then grid. Test grid. Yeah. Alright, let's see. What's wrong? Icon is not a member of grid entry. You were right. It's M label, and then it's C string. Try that again. So I wonder if I can reference this. Right? What is this push ID thing anyways? Push string into the ID stack. Well, hash string. Cool. Whoa, okay. Oh no, I shouldn't have aborted. Oh, I didn't pop some stack somewhere, or pop something somewhere. What did I not pop? I pushed something and I didn't pop it. Oh, here. I didn't pop the style color. So I pushed this. Oh, you heard the noise? You were like, oh no. Sorry about that, fam. It's like those songs where they put in like the horns, or like they put in like those like knocking sounds. You're like, what? Let me see. All right, let's go ahead and pop this. I don't need it after this point. Yeah, you feel me. Pop style color. Let's see. So let's just maybe just pop one. Try that again. Dun, 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 dun. Bum, 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 bum. Okay, let's see. Whoa. Okay, yeah, that looks right then. There we go. I'm gonna crash, are you? Okay. Yeah. Alright, cool. There we go. Yeah, so now they're their own widget. So it's not like hard-coded in here, so now I just need to see if I can get the same functionality back in. And it should be a lot better. Contents browser panel. This is the part that I'm scared of. Let's see. Okay, you know what? Let me make a little list for myself real quick. Because trying to read that's going to hurt my eyes. Alright, so first thing is double left click. I need that. Double left click. I need to be able to right click as well. What else did I do? I think I have payload stuff, so I can like open a payload and put it right here. I kind of already have that, but I'll just check anyways. Is there a label I can put on these things? Interesting. Okay, so where'd I put it? Start / stop payload. I think the right click in open space is not that's more of like a window thing. But I'll still add it. Right click in open space window. Yeah. Okay, what else? I mean, this already works. I mean, all I really have to do with this is just make sure I can left click these, so I already have that. And then I can do all the logic for that in the logic for changing directories inside the content browser still. Inside of the content browser still. There we go. I think I have pop-ups for certain things, but I already have a pop-up API, so I don't need to worry about that. Okay, so I think that's it. Alright, so now I'm just thinking to myself, there's two ways I can kind of go about this. I would just go with the easiest option because I'm kind of lazy right now. Let's see. So I could store function pointers in every entry, like every grid entry, like a left click on a right click on double left click. Yeah, I could add like a function pointer and then just trigger it depending on like which one's being clicked. I could do that, or I could add like archetypes, and then those like archetypes. So that way I can store like a minimal amount of data here, and then those archetypes are the one, like I'll just have like an idea of like which archetype I'm using, and then based on that, I can run the appropriate function, and that way I only store like if I have like a directory type, then I only have to define the function pointers for that once. And then I store the ID, and then I can just use that. I would save some memory. But making archetyping just sound annoying. What do I do? Alright, fine. I'll do an entry type. Whatever. Try it out. Grid entry type. And then I'll store a vector of archetypes, or maybe like a map or something. If I do a map, then I just need to figure out... Oh, I could use the tag, the map. I could use a set, but then I have to like have one hashable for each object. Do I really want to do that? That's kind of messy. Let's see. Yeah, the main use case for this will be I need to like use a tag to identify a particular object. So it definitely is more like a set or hash set. For sure, that's the most common use case. I could use a vector, but I don't feel like writing a whole API around vectors right now. Yeah, plus this is a widget, so like, do I really care? Okay, yeah, you know, I'm just gonna use an unordered map. And I don't know what the first part's gonna be, but I know the second part's gonna be this grid entry type. What am I gonna hash it with? So I could do a hash string. I could do like an enum. Okay, fine. I'll just use an integer. So int 32 underscore t. Okay. There we go. Entry I'll see archetypes. Like that. And then I'll rename this to archetype. And it's only two. We just do that. Archetype. Okay. And in that way, I don't need to store icon here and store the icon here. The label might be different per object for sure, but the icon won't change based on the archetype. And then I just need like an int or something. Archetype ID. I can make a template function. Oh, that's kind of messy. Okay, yeah, I think this is fine. All right, so now we have an icon. And then I just need to note somewhere. I could put a string, I guess. Do like a hash string system. I don't like hash strings anyways. I forgot how I do that. Where's my hash string API? Hash strings. How do I hash strings? Where's it? Oh, I think it's in file system. Yeah, CRC from string. So that's this one. So I can calculate a hash and get a uint32t. Oh, uint32. Okay. So I'll just use that. So I should make this a uint. Just to be consistent. Maybe I could type alias this, I don't know. Let's see. So fixed string 64, uint32t for the archetype. Icon, okay. I have a label here. You know what? Might as well. Wait, let me go back to my CRC. Okay, so these are static. So it's ran. It's runtime. Trying to see if there's a way I can like hash the string at compile time, so I don't have to keep hashing it every time. If I can figure out a way to do that right now, then I can just keep that forever. ChatGPT to the rescue. Come on. How can I get this function to run at compile time and to hash a string? And you can use template metaprogramming along with const expert. The idea is to provide perform compile time, allowing you to pass a string to the function. Implement a const expert or write a synergy that can be evaluated compile time. This typically involves using a lookup table for efficiency. Cannot be evaluated. No. Yeah, strings can't be evaluated, but constant card pointers can. Oh, that's a good point. No, wait. Let's see. So I just need to evaluate this at const expert. What is going on here? Compile time string hashing. So it just needs like a template for the size. Okay. No, I don't feel like hashing right now. Never mind. Maybe I should. Do I want to provide strings or do I just want to handle it myself? Okay, you know what? No, I'm not gonna bother hashing with this. What I'm gonna do is I'm just gonna make it clear that when you want to add a template in, that you need to provide your own key, and then I'm just gonna use an enum myself. This is like an internal function. I'm the only one that's really gonna be working on this. Yeah. So maybe I'll provide a boolean. Add our entry archetype. And then I'll add a U and for my key, and then I'll just start with the const reference first. So grid entry archetype. Reference new archetype. Entry archetypes. Dot inserts. And it's going to be E and then new archetype. And what's the results? I always forget what that is. The unordered map insert. So we get a pair back, which I'm assuming. Yeah, here we go. Insert return type. We can just use that. Const iterator, huh? Okay, so you can provide either a const reference or you can provide an R value. So move semantics work with this. That's good. I'll definitely take advantage of that. Okay, so this is number 10. Let me see how 10 works. Insert value. So 4 to 6. Insert value overload is equivalent to in place and only participates in overload resolution if blah blah blah. Gotcha. Is empty node handle. Let me see. Insert. Okay, so you can insert multiple at a time, sure. SD pair. I suppose so. So SD make pair, this one, right? Dict.insert.second. Okay. None of these are getting the results. I don't know what's going on with that. But it looks like I might end up using something like this or something like this, I think. Probably this one. And then I gotta figure out what to do with the result. You wanna go out, kitty? Do your thing. I'm getting a little sleepy. I need some breakcore. Okay. Okay, so what's the result type? So just name iterator. Iterator points to the inserted element if it took place, and iterator points to an element with a key. What's NH? New hash? Wait, no. Node handle. Got you. Let me ask ChatGPT. They usually know these really specific facts. I'm gonna grab my function too. Let's see. So I'm gonna do this. It's equal to the something results inserts something. No. What do they call it again? So iterator and bool. Okay, you know what? I'll just use this. Fine, whatever. So I'll just do an auto reference. I just hate using auto. Yeah. I did. It's now up and down, but I think I broke something with the local multiplayer, because I think before the shift was working and now the shift is not working for some reason. So I gotta check that. No, for real. Actually, yeah. Fix a bug, add a bug, right? I should probably add that to the list. 'Cause I just realized it when I was showing it to my girlfriend. Yeah. Where is... Bruh. What am I doing? Where am I? What am I doing in my life? Bug. Small one. Okay, here we go. Bugs. Yeah, I gotta add one. Okay. Fix, shift, left shift, and right shift not working properly. Yeah, I thought I tested it, but yeah, I was trying it, wasn't working, so I guess so. Okay, fine. I'll just use this, so I'll get the pair back. What's wrong? Entry archetypes. Dot insert. What's wrong? Oh, because the result type is not correct. Entry. The result is a iterator, and then success. There we go. Let's say return success. Okay, so we can add an entry archetype with the key in archetype, and then it'll just tell me if it was successful based on the key. Break sleep schedule nowadays, and I'm trying to keep to it. No, dude, keep to it. Like, don't let me stop you. But for sure, you have a good night too. Appreciate you coming by. Hopefully, I'll have some more interesting things happening next time. Let's see. Add entry archetype. Okay, so I think this is fine. Yeah, I think this is fine. Let's head back. Let's try this. So the edit archetype, the only thing it holds right now is an icon, and then the ID. And then now when we run through these, I gotta change how I run the function itself now. So if I go back, bruh. And then yeah, these don't work anymore. So now I need to get a reference to spec grid archetype. Reference. Get type. Should I do a reference or a pointer? Let's see. Does it matter? I don't think so. I think it does need an archetype. So if it doesn't have an archetype, that is an error state. So actually, I think what I'll do is I'll just do a kg assert. I'll go up here. I guess I'll do a pointer. No. Entry archetype. And it's equal to entry dot m archetype ID. So then I'm gonna do what is it? Spec dot entry archetypes dot at entry dot MID label, right? And then we're just gonna go ahead and kg assert that that's a thing, because if not, that's kind of like my fault. and then say get entry archetype. And grid element ID. What's wrong? No suitable conversion from to. Oh, right. Because, right. So we need to dereference it. Oh, no, wait. Whatever reference is, actually. Whatever the resulting thing is. And let me just be crystal clear. I'm referencing the right thing. Let I provide the memory address of this, and then we can check if that's right or null. And then now, instead of doing the entry, we're going to do entry archetype. Icon. A little bit of indirection, I guess, but that's fine. This is going to run in a loop, so I'm pretty sure... pretty sure that if we're using the same data over and over again, it should actually be fairly efficient. In the cache... I do gotta start adding... what are they called? Memory allocators at some point, but not today. Expect not thumbnail size disabled. Okay. So label and entry archetype. So that way, yeah, this is nice and stack allocated here, and this is nice and stack allocated. It's not too big of a number, I guess. Dun, dun. Okay, so I can define one of these. So I think I'm good at this point. Now I want to do add entry archetype. So yeah, I think the main thing now is to try it out. So let me head back to testing panel. Okay. So first let's add archetypes. So we're gonna do editor UI and archetype. New archetype. And you know what? I guess while I'm here, I might as well make a version of this that's R value friendly. So let's go ahead and do grid entry archetype. And then we're going to do an SV move. Right here. There we go. So we move it over here. This will see an R value, so it'll go ahead and use the appropriate stealing thing. This is the R value here, and then I just need, and then I just either provide the reference or I provide SV move, and then we can just go from there, I guess. Okay. So now we do new archetype dot m icon is equal to this. Okay. And then we don't need to do this now, but we do want to do, I think I'm going to add this up here. I'm going to do an enum class test types. Do uint 32 underscore t. I'm going to say none is equal to 0. I'm going to say display. Okay. So now we're gonna do, what is it called? Test grid dot add and nope, entry archetype. Add entry archetype. There we go. And then the first part's gonna be the key, which I'm gonna say is display. I'm gonna say test types display, right? And then I need to cast this into a U and return into a T. That's just an integer, so that's fine. And then we're gonna pass in this new archetype. So new archetype. Okay, so then label a new entry dot m archetype dot id dot is equal to u int 32 for t, and then test types play. There we go. Now right back to you. What's going on, man? Or a bird. Let's see. Alright, so we've got the display. Trying to think through this everything. I think I almost got it. So this, yeah, we add the display type for this particular entry, and then we add the entry, and I'm doing SD move. Am I doing SD move here? Probably should. Well, it's the testing anyway, if it doesn't matter. Oh, for sure, for sure. I feel that. Gotta get in the coding zone, fam. Okay, I think this is good. Sorry, I was just thinking. Let me try this. Okay, let's try this. Ooh. Does this need a name, honestly? I guess I might as well. These are not const. Yeah, no, these are all CRUD operations. So. Yeah, I really shouldn't name these specs. These are honestly classes. Not specs. These shouldn't be structs. They should be classes. The way I'm treating them. Okay. Anyways, let's see if this works. Hell yeah, it works. Cool. So now I got a copy of this. There we go. Alright, and they're all being treated the correct way since the archetypes work. Okay, that's good. So right now I'm just doing like kind of like side bugs and whatnot that I've been, you know, after finishing the whole AI thing. So right now what I'm currently doing is just let me see. Basically this like content browser is written like directly in GUI code, and I don't like it. It's really hard to read. So I'm trying to abstract it out and then put it into its own widgets. So like now I can just have like one widget for this thing. And then basically I'm going to rewrite this so that's actually using, you know, the same functionality. So I get all my functionality back. You know, just like a backend rewrite. But once I'm done with this, it should be a lot easier to like start adding like a lot of new features to this, because I want to like add new assets. And I also want to be able to like move things. Like right now I can move things, but like it doesn't integrate well with like the asset system, because where's my asset viewer anyways? Yeah, because I got all my assets right here. And then I want like the locations and everything to be updated whenever you actually move things. So end goal, I can clean up this mess because I hate it. But yeah, once I get this like cleanup stuff done, I'm gonna start working on like new game levels. But I want to get this stuff organized first before I start adding game levels, so I don't drive myself crazy. So yeah, that's pretty much where I'm at, and I think it works. So that's good. I'm trying to think what's the next thing to do. I want to add it. Yeah, I wanted to add these functions to it. So double left click, right click, start and end a payload, and then right click and open space, but that should be for Windows, not the widget itself. So let's see. Let's add this double left click real quick. So I believe I can just put it right here and do just an SD function, I guess. Just do a void. Yeah, just void for now. M on, what is it? On left click. There we go. Yeah, and you know what? I want to provide a clear entry reference. Let's see, on double. Okay, is that another one for just left click? Is that another one for right click? And is that another one for double right click? Yeah, that's probably not a thing. Double left click, right click. Was there anything else? Let's see. Oh yeah, and on payload. Let's see how I want to do that. Handle input. Somewhere else I do payload stuff. I can do payload stuff here. Yeah, let me see. Let me rename this. Receive payload. Payload back. Receive payload forward. There we go. And then I provide a string, but maybe I shouldn't provide a string. Let me go see how I do this. Oh yeah, I'm doing this here. It's not good. I finally got a fixed string class, so I intend on using it. Let's see. That should break a few things. Let's see. Or do I even use ID here? Hold on. Oh, I guess not. Sure. Well, because it's not necessary. I renamed those, and then let's see. How do I deal with payloads? Where are they at? Here it is. Accept payload. All payload types. And I think I do strings here. So you know what? Instead of doing this, let's do fixed string. We'll do 64. I don't think I need any more than 64. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21. Probably 32. Let's see if that works anything. Yeah. So now instead of being a string, it's going to be a fixed string 32. So I can do fixed. No. String 32. Or I could just do a const car pointer, I guess. Anyways, do C string. Oh, this one goes crazy. Let's switch it over. Okay, where did I switch this to? So now I'll handle it with a fixed string 32. There we go. Or actually, no. What am I doing? Let's do a const car pointer. Mao kitty. She said, "Let me in." Over. Got it. There you go. Okay. So now do payload name dot c string. You're way more efficient. I don't call it dot c string. I call it c string. Because for some reason I like capitals. So fixed string reference. I wonder if I could directly use them as const car pointers. Probably not. You know what? That's an API I should probably add. So for the fixed strings, let's do like a. Let me ask ChatGPT. I always forget how to do operator overloads. Can you give me an operator overload to convert a value that for converting to a const pointer implicitly. There we go. Where is the operator overload? Implicit conversion from where? Oh, right here. Okay. Okay. So we just want to return data buffer dots data. So I think that's what I do. Yeah, C string. Okay. Okay, yeah, so that should implicitly be able to be used as a const car pointer, and then, oh yeah, if I have it like that, then I'm gonna do this. Yes. Cool. Even better. Okay. So this is going to be a pointer. And there we go. This one is just implicitly good. And I think we're good. Yep, const cover pointer, void pointer, and view at 32. The memory is managed by mGUI, so should be fine. Alright, so now I want to steal this and put it over here. On create payload for this particular template type. We're going to see payload. Okay, so now I can do double left clicks, I can do left clicks, right clicks, can handle those appropriately. I can create and receive payloads depending on the situation, and now I just need to actually handle this. So how do I do that in the concept browser? Let's see. This payload. Oh yeah, these are broken. So this is now a const car pointer. And everything else looks fine there. Let's see. So this is going to be okay, so I begin a drag drop target and then accept. So this is a target. And I want to do source. This is how I do it. So I do source, begin source, and then for the path, how do I do with the path? Const wildcard t item path, and then for the item path, so set. So what is this again? So we have the type, and then we have the data size, and then like I guess a condition. So I guess like a predicate I can use. Okay, sure. Okay. So then browser file type to payload string. Okay, so then this is the little conversion that I use currently. I'll probably yoink this. Then yeah, file type. So this is the payload name, and I convert it into a C string. Okay, then the payload is the path, I guess. And then there's this weird thing where I'm getting like the length of it, I guess. What's going on here actually? I guess. And then I can do whatever I want here though, so like I don't okay. Times size of Y chart, right? Because it's gonna be the length, but then it's gonna be 2 bytes each. So I'm GUI condition once. Okay, this isn't too bad. So let me see if I can add this. And then this is the drag drop target, depending on the situation. So let's go back to the grid. extract. Okay, so I think it's in between here. They handle payloads. And I'm gonna paste this here. And I'll say if entry archetype dots on create payload. So if that's a thing, and drag drop source, and then we start it, right? And then okay, so this is gonna be interesting. So when we set the payload, it's gonna be different from creating the payload. Okay. So again, it's a type, data, and then size. I'm not gonna work with the condition. I'm just gonna put that as once for now. So basically, these are the three things that I'm gonna need. So what I'm gonna do is above here, I'm gonna add a little struct. When is all this? Oh, no, not here actually. So we're gonna go up to the grid spec. And then above this, we're gonna add one more thing. Payload. What's it called? Oh, there's a thing. Okay, I got you. Okay, wait, I gotta think about that for a second. I'm gonna use the restroom real quick. I'll be right back. Oh, 4 minutes. Maybe I'll think about it too. Ooh, all right, I'm back. What I was thinking about. Oh yeah, this payload thing. So, yeah, this is interesting. Oh no, wait, actually, no, this is fine. Now that I think about it, I was like, wait, how is IMP managing the memory with a void pointer? I'm like, no, they have the size. What am I talking about? Okay, never mind. So I'm gonna say, let's see. What is this called? Payload. So I'll probably put this higher because I might use these payloads all over the editor. Grid. Yeah. So instead of this, I don't want to use 32T. Or should I use an SCD size T? Maybe an SCD size T. Might be better. Yeah, because it's a size, so might as well stick with the standard. This is the one for this one, and then for this one I'll go ahead and make sure it's consistent as well. Size T. Okay. Yeah, because this is the memory size, void pointer, const card pointer. Right. And then... yeah, on receive, you want to use these. But on create, we want to manage a payload. So... basically, what I think is going to happen, I just need to figure out what I'm going to call this. Yeah, let me go back to my function and check real quick how I use this. What is this called? This is called drag drop payload. Drag drop source. Okay, let's call it drag drop payload then. Sure. I'll call it drag drop payload. Okay. And it's basically going to take, yeah, all three of these things actually. The only thing is if I provide it as a const card pointer, and the stack falls off, then we're going to be accessing like undefined memory. So actually in the actual payload itself, I want to put fixed string. I'll do what's a good oh, no, you know what, 64. Yeah, because I have like payload definitions here. Yeah, I have these payload definitions, and then these payload definitions are fixed string 32s, so don't fix was not broken. So label, I'll do a void pointer, data pointer, and then I'll do a std size t. I'll do data size. There we go. And I'll bring this way up. So I'll put this like up here, I guess. Yeah, I'll put it right here, I guess. This is in the middle. I'll put it on top of my type defines. There we go. So now, if you want to receive a payload, we just get provided like everything like directly. But if you want to create a payload, we just provide the drag and drop payload reference. New payload. So I provide this, and then basically inside of whatever functor or whatever lambda You just have to fill up the payload however you want to do it. So this one will fill the payload, and then this one will receive it. And then, yeah, we're good. And let me figure out where else I did that. So, yeah, same thing here. Well, both of these are received, so these are fine the way they are, actually. Yeah, there's no reason to do, like, a drag drop from a navigation header. That doesn't make any sense. So, yeah, that's fine. Okay, I think that makes sense. So let me head back to whatever the hell I was doing. Alright. So if we have onCreate payload and begin drag drop source, then we'll go ahead and do, go ahead and call it. But first we need to provide a drag drop payload. New payload. Okay. And then we need to call this functor with the new payload. There we go. Okay, and then once we call that, whoever is calling this function should like provide like all the necessary details and whatnot. Suppose I could do some asserts here. I guess if someone like messes it up or whatever, or someone being me, I guess. Let's see. I'll say new payload dot. I'll assert that data pointer is valid, and then I'll also assert that could I provide without a payload? I mean, maybe you just want to provide the name. Sometimes you don't actually want to have a data pointer. So maybe that is a valid case. Assuming if you provide like a size of 0 for the data pointer, then there's probably no payload. I mean, there is no payload in that case. So if you just leave it alone, I could just do a check whether the payload is 0. So that way you don't have to do the payload if you don't want to. So then you could just provide a name and that's fine. So yeah, I guess I don't need to assert. Never mind. Okay, so we rerun this and then we just call the relevant function. So here, it's going to do new payload dot label. That implicitly converts it to a C string, yep. And then path. Yeah, what is this? This is the data pointer. And this is the data size. And then this is always condition once. So I'll provide new payload dot data size. And then new payload dot data pointer. And then basically at that point, this data pointer is what is it called? Its memory is taken over by ImGUI, so I don't have to worry about it. So once it falls off the stack, we're fine. So I think that's it, as far as I can tell. And then we just do the corresponding one for receiving. On receive payload, and I think I already have like some ways that I do this. So yeah, this is an additional check to see if it's active, but in our case we just want to check whether, because this navigation thing will either be like disabled or enabled, which would prevent you from doing drag drops. But since we don't have that, that's not relevant for us. We do have this like allow drag drops like thing. Should I add that? Okay, well, whatever. Let me just add all this really quick. So here we're gonna do This is irrelevant for now. And this is irrelevant as well. But we need to replace this with entry archetype. What? On receive payload. There we go. And then it checks through all of like the available payload types, which now that I'm thinking about it, maybe it should just be a set instead of a vector, so I don't have to run through the whole thing every time. Yeah, that's pretty easy change. I'll just do that. So instead of being an array, we're gonna do a set. Unordered. There's only one of these defined here anyway, so it doesn't matter. And then we'll just have these wait, is this hashable? Let me see. What is the hashing function for using entity string inside of an unordered set? Ordered set. I'm assuming it's implementation specific, but I'm using SD string instead of the hash function provided by standard library. It's used to define the hash. Okay. Use inject with SVG string. Insert hello. I mean, I get you can use it, but what's the hash function? Okay, so if I wanted to provide maybe Google knows. How is the hashing std string implemented? Perfect solution involving the libraries. You can use hash to hash string. If you decide you want to add security, yeah, you can download a crypto library. Yeah. This isn't going to secure hash. Yeah. Using today, you can use std hash. Yeah, get that. Okay. Oh wait. For some theory, hash types for some using hash. Let me see. I have a custom string class. How can I use the same hashing std string uses? Create custom hashing delegates hashing to delegates it, huh? That doesn't seem efficient. Yeah, because then you're doing like a std. What? Ugh. I do not like that. No, I want my own hashing function then, because that's just silly. Oh, wait. std hash. No. Custom hashing functions for strings. Okay. First, it doesn't matter which practice most are good enough, but if you really care, you should know. The way goes to this is for your own protection, old and dangerous. Yeah, I guess so. I mean, it doesn't need to be like safe or anything. It just needs to hash correctly and give me a good distribution. Okay. Prime numbers, hashing methodologies. Let's do that. Saying it and being a hash function, common building blocks to clear bitwise operation. Yeah. So for efficiency, I get you. Let's see. Okay, this one takes in a const card pointer and the length, and then it hashes it. Sure. That has the following additive and rotative string hashing algorithm. The following is you very usefulness in functionality. I mean, as example for learning how hashes operate. JS hash. Okay. General function license. Free use of the general so it's permitted under the guidelines in accordance with the MIT license. Okay, so I could use it. Sure. General hash functions is compatible with the following new compilers. Yeah. So has some simple or dispute it, but it was recommends the use of a hash function that employs hashes found a particular algorithm. But tweaked for 32-bit operations. I want 64, so this comes from slavery is simple hashing using a strange set of possibilities. But high throughput is a requirement for recommending hashes using. We should consider unrolling the internal loops and adjusting the hash value memory footprint to be appropriate for the target architecture. Oh, okay. Which one do I use though? Yeah, you know what? I'm gonna go with one of the most efficient ones ever published. Let's go with that. I'm going to save this and I'll read it later. Alright. Then how do I implement a custom wait, maybe they just did it somewhere here. Yeah, hashing function for my custom class so that I can use it as a key inside an unordered map or whatever. Okay, so this is how I do it. So this is the operator. Where did I do it for? I think I have another one for like UUID. Let's see. Okay, yeah, same thing. So I have to like implement it outside. Sure. So where did I paste this thing? So I'm hashing, what am I hashing again? Totally forgot. Oh, the strings, right? Yeah, I'm hashing strings. So let me go to the fixed string. Okay, here, and then I'm going to go ahead and add outside of the definition. I think that's how they have to do it. Like this. And then we go back to UUID. Go ahead and yoink this. Yoink. There we go. Struct hash for yeah, it doesn't know what that is. So it's going to be a. Oh, do I have to do it for every type? It's literally a template, so I could template it. What's going on over here? Oh no, here. So hash. So SD size t. Cardano SD has no member SD size t. I would beg to differ. I think it has a size t. Anyways, I think I remember this just had UUID in it, so this one's going to be fixed string with buffer size. What do you mean there's no size t? It's right here. Oh, it's because it's in the same namespace. So it's just size t, isn't it? Oh, that okay. That's why. I was like, wait, what? Hash fixed string. Okay, and then I need to do a Cardano because it doesn't know what I'm talking about. Okay. Template array is not allowed in declaration of a primary template. The template argument list is not allowed in a declaration of a primary template. Oh, is it really not? Okay, let's see. ChatGPT, help me. I don't know. Yeah. What am I doing wrong with setting the hash function signature template? But I mean, I get that. Hash function accepted const. Which is, I mean, I get that. Okay, so it will accept it. Let me see. So let me do this. And then I want this. Unsigned uint hash is equal to string. Okay, so we want to do okay, so I think it's using it as that, so I can probably just do a fixed string. And since I think it implicitly turns into a const card pointer, it might be fine. Signed int. I guess it's fine. Hash string fixed string. Title area is not allowed in declaration of a template. Okay, here is my new function. Saying my primary. What is it? Template argument list is not allowed. A primary template. In case an issue with how you're dealing with hash structs for the main problem seems to be that you're trying to define hash struct for a template class without properly qualifying the template operation. Yeah, I probably should. Try this. See if ChatGPT knows what it's talking about. Oh no. A template argument list is not allowed declaration. A template argument list is not allowed template. What is that? This looks like a partial illustration without proceeding. Template type name struct needs a primary template. Providing a partial template submission, but haven't declared the corresponding primary template. That is, there is no class template that you must specialize in the first place. Otherwise, that makes sense to specialize something that isn't there in the first place. So this needs to provide a declaration of the primary class template. So you're telling me I can't do this unless I can't do this hashing thing unless I have like a very specific version of it? That's annoying. Template type name types struct. Right. What is that one? Oh hey, what's going on? I'm just working on like string stuff right now, so I'm not sure why this is broken. I'm trying to specialize something that's already, yeah, I don't know. How do I implement this? This is so weird. And ChatGPT has no idea how to fix it. Oh, for sure. Well, I mean, I'm not really at that point yet. Like with my games, but like, what is it called? If I do get to that point, like, I'd totally be down. I mean, right now I'm just making Pong, so it's not much of an artistic vision for Pong, if you know what I mean. Let's see. Fix string length. To get the length of the string, iterate over it correctly. Bruh, what is going on? Template. So it's saying I can't template a template? Bruh, what? Oh, sure. Well, I mean, leave a link. I'll take a look. Well, let me see if I can open up your thing. Where did I put it? Bruh. Okay, there we go. Okay, now my thing's broken. Wait, hold on. What is going on? Oh, I can like close it right there. I got you. Oh, sure. I'll go ahead and save the link. I'll take a look a little bit later. Let me see. Yeah, I'll go ahead and bookmark it. Oh, no, it's nice though, for sure. Oh, yo, Treasure, how's it going? I'm just working on string stuff right now, so still trying to figure it out. Okay, yeah, I see you like working in different styles too. That's cool. Let me see. So yeah, if I ever get to that point, I'll keep your link and I'll let you know. I'll be down. Okay. What is going on with this though? Hash. Bro. Wait, actually, how did ChatGPT tell me to do this earlier? Jupiter. Bro. Yeah, this one, STD, and then the specialization of this. SD hash. Okay, so this is when I threw the whole thing at it. What did it tell me to do before this, though? Custom string. Oh, maybe I needed to find it inside of the object, I guess? Wait. So, I have my data, whatever. Car pointer, data, whatever. Next, create a hash function for your custom class, so... Custom hash. Oh, am I using this hash thing? Yeah, I don't like that. Yeah, I have to, like, define that every single time. That's kind of annoying. Yeah, no, I don't know. I don't think. Because I know how to do this if I like specialize it, right? Like if I go to oh, wait a second. Like if I did this for like one of these particular specializations that I have, then I could get it to work. But it's really annoying to have to like provide a hash for every single one of these specializations. And then like, what do I do if I want to use a custom one? Like, just me, I guess. Good thing. So like, if I do a specialization like this template, and then instead of doing this, I just do like 32, and then 32 here. That should work, right? Hash is not a template. Wait, what? Oh, because... No, wait, what? Oh, because I gotta get rid of this. Wait, am I misunderstanding? What's wrong? Okay, now you're mad at me. I don't understand that. But yeah, this one just takes instruct hash Cargano UUID. Yes, this is providing a template specialization specifically for Cargano UUID. So if I yoink this over really quick, and then do this, right? Oh, wait a second. Are these... Maybe it's because I have this. Maybe it's because of this. Okay, there we go. Now it's not yelling at me. That's good. Then length, of course, is like fixed string dots. Yeah, string length. No. Operator, for sure. String length. Or I could probably just like save it right here and then just go through it, I suppose. Well, you'll need to get it once, so might as well put it here. And then the other thing is I need to probably do a const card pointer for a string. Current string. I'm gonna say car iteration. since that's essentially what it is. I'll do fixed string since it has an implicit, what is it called? Conversion. And then I'm just going to use car iteration. And car iteration. There we go. So that works. And this one's just mad at me because of that. So now I'm wondering, like, do we have one for like to do temp? Okay. If I do this for like template specialization, but I do std, I don't know, just use size d, and then buffer size, right? And then I do, instead of 32, I do buffer size. And then instead of this, oh, is it actually working? Please tell me it's actually working. Oh, is that actually, okay, wait, so that's what I wanted. Okay, so then I get rid of this. Yeah, so we just iterate over the string length, right? And then we just hash it. Like something more verbose. Character iteration. Or iterator. That's probably what I want. And then just do a unsigned int I. Let's do 0 near this, and then return hash. Okay. So this is garbage. Get rid of this. And is that actually gonna work? What's wrong over here? Oh, okay, yeah, I was doing the hashing over here, so I don't need this anymore. Yeah, I was just putting it in the wrong place, I guess. Okay. Totally forgot what I was doing prior to this. Oh yeah, I was trying to get like, okay, so I was trying to get this working so that I can add these strings to sets. That's what I was doing. So now if I go to what is it called? Brain work. Edit the editor UI. That's what I want to go to. And real quick, I'm gonna make a call really quick. I'll be right back.
May or may not know it, but there is a good chance that every time you turn
Okay, I'm done. Let me see. Never mind on the 5 minutes. Okay, so let me. Oh, no, this is the CVP file. I don't want that. I want to find this little thing. Here we go. Here it is. So an order set of these, right? So now this should be fine because since this is hashable, now then I should be able to order them in the unordered set now. Then basically I just need to figure out where do I use these. Like I could iterate through them. Or I could do if not contained oh, do I have to do like this? Exit payload with the name. Seems inefficient, doesn't it? I don't know. Yeah, it seems a bit inefficient. So this is just saying if there is a payload. Okay, wait a second. I got you. Yeah. Okay. Sure. If S all payload types not contained, so yeah, I can't do that here because it needs to query every individual one. It's really annoying. Yeah, there's some other like query functions I use other than accept payload. So maybe we should stay a vector then, I don't know. Maybe I didn't fully understand that. So the entire drag drop is you begin a drag drop source, set end, begin, accept. Here, if I go to accept, is drag drop being accepted? Is this like an internal function? This is drag drop active. Drag drop active. Oh, I'll be right back. What, is this like a private API or what is this? No. Oh, these are. Oh, okay, okay. So this is like internal API. I got you. Do I want to expose internal API? Hmm. Accept drag drop payload. Is drag drop payload being accepted? Yeah, these are internal APIs, so this is the external API, I'm assuming. Okay, so I'm starting to realize like how I should go about this. Yeah. Okay. Okay. I think I understand now. So I'm gonna put that thing back to being just a vector. So let me undo this. Okay. Let me head over to S payloads. I'm gonna put this back to being a vector. Actually, no, it's being an array. Yeah, it's just an array. And I'll leave it the way it is. And then basically, we're just going to provide like a subset of these for like each, what is it called? For each like payload acceptor, right? So it's only going to check like a certain number, then it's not going to check every single one every single time because that's ridiculous, right? So yeah, I'm gonna write that down really quick, and then that'll be like the next thing I do when I come back. Let's write it down really quick. Actually, maybe I'll just type it out. Put it in my little notes. Yeah, these are almost done. Let's see. Drag. What am I doing? Brain. Oh, right. Provide subsets of payload accept types to each navigation widget and grid widget. So I want to do that. Yeah, I'll do that next time. All right, let me see if there's anything I need to update for the progress board really quick. I did do this, so I guess I can put that into completed. So yeah, I'm still working on this right now. So all right, if anyone's watching, I'm gonna head off right now. If anyone's watching on YouTube, I hope you have a good day. And yeah, I guess that's it. I'll see you guys next time. So I'll come back 12 p.m. tomorrow, same time. So all right, later. Oh, actually, wait, before I go, let me go ahead and push this code. Actually, should I push it right now? Let me think. Let me make sure this runs first. If it does run, I'll go ahead and push it. I don't think I modified the, okay. Undeclared identifier error grid entry. He doesn't know what a grid entry is? Is it because grid entry is not above here? Yeah, that's probably a consideration. Build. Oh, nope. Alright. Let's see what other bugs pop up. Because I think I saw a few other ones. I don't think I modified the on game at all recently. Or wait, did I? Actually, let me go look at my repository really quick, because I don't remember if I pushed the changes I made recently. Yeah, what did the last commit say? Change input mode to input map. Oh yeah, this was after I fixed up the input. Okay, so yeah, I don't think there's any changes I made. What is that? Receive. Is it really not? Receive. Wait, what? Oh, no, yeah, of course it's not. It's on receive payload. Yeah. And then on receive payload. Takes in payload name. Wait, there's no on receive payload? It's probably because I need the archetype. Okay, wait. Let me cancel this really quick. I think this is, okay, I think this is the next part of the to-do, so let me just comment this out for a second. Okay, there we go. Okay, cool. Looks like it compiles. So let me go ahead and push these changes and then I'm gonna head out. Testing panels I don't care about talking about because they're just random things. Let's see. The content browser? Oh, let's see. Add fixed sized strings to use throughout engine at fixed string h. What did I do to bit field? Okay, can I undo this because nothing significant actually changed here. Base. Okay, I do want to add that. Yeah. Provide fixed string to base.h. What did I do to operations? Not much. I didn't actually add anything. This fill card data. Oh yeah, I was thinking about adding something, but you know what? Yeah, I didn't actually add anything. Let me just undo this. Still registering is being updated, but yeah, I didn't really do much. What did I do with the editor app? Literally nothing. Okay, sure. So yeah, really the only major changes I made was add grid and navigation in the bar. navigation widgets bar widgets editor UI.h. So add strings and new grid slash navigation widgets slash .cp. Okay. Okay. I'll go ahead and push these as well. All right. But yeah, so I'm gonna go ahead and head off then. I hope anyone is watching. Have a good day, and if you're watching on YouTube, I hope you have a good day too. I guess that's it. All right, later.